Okay, let's start again. Thank you so much for being here. Welcome to the third session of our micro-learning program. As you know, this super concentrated trainings speaking about most important themes in the moment on ventilation. As you know, today we are talking about ventilation solution for radon gas mitigation. I think it's a very, very trendy theme, very, very trendy topic. So I hope you enjoy it, you find it interesting. So as always, we will have a Q&A time at the end of the presentation. So if you have any question, you can write down in this moment until the end of the presentation. You will have the tag questions in your control panel. So don't decide and ask so many questions you want. And also, as always, at the end of the presentation, I will share with you this presentation in PDF. So don't worry about make any screenshot. If you want, you can, but I will share with you the whole presentation. So let's start talking about this ventilation solution for radon gas mitigation. We are talking today about indoor air quality, as you know, one of my favorite topics. Let me introduce myself. In case you don't know me, I'm Carlos Martinez. I'm responsible for the training and knowledge transfer department here in SODECA. So let's talk about one of my favorite topics, that is indoor air quality. And if we talk about indoor air quality, I need to begin with William of Orange, king of England and Ireland in the 17th century. For those that didn't know William, it was a king that have so many problems with the arcs of the state. The British crown was heavily indebted due to several wars against France. So this King William has had a revolutionary idea. He invented the window tax. Why the window tax? Because the concept was simple. Wealthier people will have larger houses with more windows, and where the windows were visible from the street. So he want wealthier people pay more taxes than poor people. So it was a revolutionary idea, a simple idea, but as you know, every law has his loophole. So people started bracket up their windows to avoid paying these taxes. This can sound funny, and it was funny in a day. Actually, this is a real street in London, Albert Street. You can visit if you want. But this tax not only altered aesthetically the building, but also reduces ventilation and natural ventilation. And this led to one of the largest tuberculosis outbreaks in the United Kingdom history. Because as we know, if we limited the fresh air we are introducing in our buildings, in our dwellings, this can impact severely in the indoor air quality of these buildings. So bear in mind that even these political decisions can make a tremendous impact in the health of the people. Okay, so if we need to find something similar in nowadays, we can talk about rehabilitation strategies. Why? Because nowadays is the perfect era of the rehabilitation, of the retrofit. I'm sure you could see in all the cities around the world these strategies to try to reduce the energy consumption, the increase the energy efficiency. And if I need to select what strategy is the king or the queen of this rehabilitation, of these retrofit strategies, I will select the improvement of the thermal envelope, because it's really efficient. Okay, if we apply this approach and we renovate and we increase the isolation of our buildings, we will save so many energy of the cooling and heating systems. But we need to take into account the global photo. Okay, this is a very good strategy for energy savings, but if it's not accompanied by an improvement in the ventilation system, could lead to this. And what is this? This is moisture accumulation, fungi accumulation due to the same that occurs in inland 500 years ago. If we improve the thermal isolation of our buildings, we are also reducing the natural ventilation that we had in the past due to the cracks, the not complete isolation of the building. So if we reduce natural ventilation, we will have accumulation of pollutants. Moisture is one of these pollutants that may be dangerous for us, but as we will see in a couple of minutes, is not the most dangerous pollutant. Okay, the difference is that we can see this moisture, we can see this fungi accumulated near to the windows, so we can notice that we have a problem. But there are other pollutants that are invisible to us. And that's the case of radon. What is radon? Okay, radon is a radioactive gas, a natural pollutant, in fact, that came due to the decay of another radioactive element that is uranium, okay? And where is uranium? Normally, 90% of the uranium is in the soil, okay? If we divide the global soils in two, we can find granitic soils and clay soils, okay? In the granitic soil, in the rocks, we will have uranium that is radioactive, will decay in radon, and radon is a gas that can release from the ground, from the soil, and reach the basements and the first floors in our buildings, okay? Once the radon is in the building, we can breathe it, and the radon will reach our lungs and will provoke several damage in the lungs. Why? Because the radon will continue the decay because it's radioactive. So many times when a gas or an element decay emits these alpha particles. These alpha particles are very energetic and can modify our DNA and can provoke, as we will see in a couple of slides, lung cancer. So radon can reach our buildings from the soil 90% of the times. Can be also present in construction materials, because if we have construction materials made of granitic rocks, we will have uranium and we will have radon. And it's also present in the water, in thermal waters, for example, water under the floor, okay? So that's what is radon, how radon enters in our buildings, okay? We will have two different factors that influence the entry and accumulation of radon inside the buildings. We need to bear in mind ground factors and construction factors. Okay, speaking about ground, we will have different soils, as we said. So if we have granitic soil, it's more probable we will have radon problems. We also will pay attention to the permeability of the soil, because if it's a very porous soil, is more probably radon can reach our buildings, and also the degree of saturation. When we speak about degree of saturation, we are referring to water, okay? If we have naturally water in the ground, this could be an important barrier to avoid radon reach our buildings. But if the soil naturally is dry, but it's getting bad weather, we have rains, we have this rain introducing in our soil, this can make a positive pressure inside the soil and obligate radon to release from the ground and reach our buildings. So we need to pay attention to these factors in the ground. On the other hand, we will have always different kinds of construction characteristics that will avoid or permit radon reach our buildings. Okay, we need to pay attention, and we need to bear in mind the proportion and the permeability of the envelope we will have in our building. Okay, if we have a basement, for example, is most probable that we have all the facades in contact with the ground, so will be more dangerous for us. Also, the construction details, we will see that it's not the same if we have natural ventilated chamber or mechanical ventilated chamber or a space between the ground and the first habitable space. It will be more or less dangerous for us. And also, we will have through installations like pipes, like light installation, these kind of things that came from exit of our buildings and can't be a weak point for the radon enters inside our buildings. Okay, so knowing what is radon and how radon enters in our buildings, let's see what's the problem with radon. The problem with radon is that the World Health Organization calculates that almost 14% of global lung cancer cases are due to radon. Okay, it's the second leading cause, only behind the smoking. And it will look into the data of all the cancer diagnoses around the world. We will see that lung cancer is the second most diagnosis. So we have the second cause of the second most diagnosis cancer. Okay. However, it's not the only problem. We have another problem that radon has a synergetic behavior with the smokers. So if you are a smoker and you have exposed during your life high concentration of radon, you will have 10 times more possibilities to develop lung cancer. So that's the real problem with radon, and that's why radon is more and more present in our legislations. Okay, because it's a tremendous hazard for our health. As I always say, we need to bear in mind that diseases are not matter of bad luck. Okay, we tend to think that diseases are related with genetics, with bad luck, but in fact, most of the diseases are more related with environmental factors and lifestyle. Okay, if we smoke, if we drink a lot, if we eat badly, we will have more probabilities to develop a disease. And it's the same if we live, work, or go out in buildings that are not prepared to mitigate, to eliminate so many pollutants we have to take into account. So environmental factors are the key to enlend the life of the people. So I assume most of you are related with building construction, so we need to bear in mind that we have the possibility of change the life of the people, to improve the life of the people. Okay, so let's talk about the problem of the radon that, as you can imagine, is a global problem. Why? Because granite soils are one of the most common substrates in the world. So in those cities, in those towns that are built over granite soils, we will have radon problem. This, for example, is the European indoor radon map made by the European Commission. And as you can see, radon is a problem in mostly all the countries around Europe. I'm sure if you look for maps in your countries, specific maps, you will find or radon maps or granite or a map of the soils of the country. If you have granite soils in these cities, certainly you will have radon problems. It's the same for United States, it's the same for Canada. I'm sure in every part of the world you will find territories with radon problems because it's a global problem, and we need to face it in a global way, okay? To do this, to face the radon problem in a global way, we will have several regulations around the world, okay? For me, it's very difficult to focus just in one when we are doing this micro-learning, because we have people came in from around the world. But today we are talking about, for example, the European regulation, okay? And the European regulation, speaking about radon, is this Council Directive 2013-59, most known as Euratom, that is set the basic safety standard for protection against the dangers of the exposure to ionizing radiation, okay? Inside ionizing radiation, we will have mostly radon, okay? So this regulation basically establishes the thresholds we can't be over, or we can't exceed, okay? And it's the same threshold for both workplaces and homes. And it's I need you to bear in mind that it's a political threshold. It's this 300 becquerels per cubic meter, okay? 1 becquerel is 1 decay in the number of decays in a second of this radioactive gas. So it's a unit of concentration, okay? Becquerel per cubic meter. As I said, is established for Europe in general in 300 becquerel per cubic meter, but every state can set less threshold, okay? Reduce the threshold permit in each country. As I said, this is a political threshold because scientific studies say to us that there is not secure limit, okay? There is no secure threshold. It's a matter of probabilistic, okay? If you are exposed to high radon concentration, but just a couple of minutes per day, is not as problematic as if you have a medium concentration but long exposure to this gas. So as I said, every country will have his threshold. I encourage you to browse, to check what is your real threshold, but our main objective will be always reduce the concentration of radon, because there is not secure threshold, okay? So as I said, we will have this Article 54 speaking about radon in workplaces, and the Article 74 more related to dwellings, more related to homes. But basically, regulations are saying to us that we need to test radon, and we need to take care of the solution in case we have a problem with the radon, okay? So we have seen what is radon, how radon reaches our buildings, how radon can damage us, what are the risks of radon, and some regulations. Let's talk about a specific regulation here in Spain as an example, because I'm sure all the regulation kind of be similar mostly in Europe. So in the case of Spain, we have the technical building code that establishes the same threshold than Europe, 300 becquerels cubic meter. And here in Spain, we have 3 potential risk zones, okay? In the zone 0, okay, we established that we don't need extra measures, extra strategies to eliminate radon. Is this yellow part of the map you are seeing. This map was developed by the Nuclear Council here in Spain, but it's an inexact map, okay? The number of measures, the numbers of tests you could do in a country is limited, so it's more a guide than established map and sure map. Okay, so in the zone 0 we don't need to take care. In the zone 1, medium risk, we need to project a protection barrier in all new buildings, and in the zone 2, the high risk, we need to project this protection barrier and a ventilation solution that could be ventilated containment space or ground depressurization. So let's see one-to-one what these strategies are and how we can design and project everyone, bearing in mind the key factors in the design. Okay, as you can imagine, we will pay more attention to the ventilation solutions than to the isolation solutions, but generally speaking, we will have two different strategies. Before radon enters the building, normally for new buildings, and after radon enters the building, that normally is in old buildings, okay, or existing buildings, okay. So we will have isolation solution and ventilation solutions that we will talk in a moment, okay. So starting with isolation strategies, mostly are two, and these two are related between them. As I said, there is a protection barrier that we can plan before we build the building, and basically is a plastic barrier that we install between the floor of the first habitable space and the ground. Okay, is this plastic barrier you can browse in internet, and there are so many options. And normally we combine this strategy with the sealing of joints and cracks. Okay, this is really important because radon, as other gases, can find the weak points in our buildings. Okay, so it's really important to combine this protection barrier with the sealing of joints, cracks, fissures, every point that radon can find to reach our buildings. Okay, so that these two are mainly the isolation strategies, are really effective, but we have a problem that are only useful for new developments, new buildings, because if we have an existing building, it's so difficult to remove the original floor, install this protection barrier, and install again the floor. So speaking about isolation strategies, we only use them normally for new buildings. Okay, that's why ventilation systems are so important in radon mitigation, because mostly always we need to take ventilation into account. Okay, and for this we will have 4 different strategies using ventilation systems. The first is to ventilate a containment space. This containment space is mandatory in Spain from, I think, from 2006, and is an air chamber between the ground and the first habitable space. Regulation in Spain think in this air chamber because we were worried about moisture, okay, about humidity, but in fact is also good for avoid the enter of radon in the buildings. Okay, so if we have high concentration of radon in this area, we can project a ventilation system, mechanical ventilation system for this containment space. Okay, we will have 3 different strategies. We can install the duct we need inside the building, outside the building, and we can install the fan just close to the facade in order to don't make a larger duct. Okay, so these 3 strategies are very good options, and all of them has in common the special fans we will use or we will recommend to you. Okay. So what are the key points we need to bear in mind if we are designing this containment space ventilation? First thing I need to say to you that radon mitigation is so complex that normally we don't have so many regulations that say to us, okay, you need 200 cubic meter per hour of ventilation to avoid the problem. Normally we don't find this calculus in the regulations, so we need to speak from our experience, from our know-how. Okay, so using our know-how, the first key point is to use mechanical ventilation instead of natural ventilation. Okay, scientific studies show us that natural ventilation only works in the 50% of the cases. Okay, as I always say, natural ventilation is an act of faith. Okay, so if we have a problem with radon, we need to be sure we need to use mechanical ventilation. Okay, we can just use a mechanical ventilation for the extraction and to have natural ventilation using the natural entry of the air. Okay, I will recommend you moreover to use continuous efficient ventilation. Okay, if you go to our webpage or to our catalogs, you will find different types of the same series of fan. For example, neolinear. You will find the basic neolinear or this with /EW. This EW means that the motor that is using this fan is more efficient. How much efficient? Approximately 35% more efficient than the normal one. And this is very important because we normally will plan continuous ventilation in order to avoid the concentration of radon. So if we need a 24-hour ventilation system, we need to select the more efficient. So another recommendation will be to find the more efficient fans inside our catalogs. Okay, if you are a fan with 2 or more speed motors, better, because we can adapt, we can adjust the flow to the necessities we will have. Okay, our experience says to us that if we have this air chamber, is enough using 1 to 2 air changes per hour to mitigate, to eliminate the radon. And there is the possibility of make an overpressure, a positive pressure inside the space. Okay, instead of extract the air, introduce some a high quantity of air in order to make an overpressure. But I will explain the overpressure in the next slide. So I reserve this part for the next couple of minutes. Okay. The second ventilation solution we can use is the depressurization of the soil. Soil depressurization is basically the same that we are doing with the containment space, but we are extracting directly from the soil, directly from the ground. Okay, in case we don't have this containment space, we can install a duct direct in the ground and use the same configuration for the fan for the extraction of this radon. Okay, we are obligating the radon to go through the pipe, to go through the duct, and not enter in the house. Okay, the same concept we speak about efficiency and the speed motors are the same for this solution. Okay, we need to take into account exactly the same because the solution is so similar. Okay. Apart from the fan, we need to take into account also the collection elements. Okay, we will have to install, we will need a collection element. Basically, we have 2 in the market: the collection wells and the perforated pipes. Okay, perforated pipes you can find in any supplier you have of ducts. And the collection wells, you have 2 options. You will find in the market collection wells fabricated. Okay, make it expressly for this solution, or you can build up your own collection well. How? As you can see in the image, you can use bricks and to perform as a collection element. If you put the holes in contact with the ground, you will have a natural collection elements. Okay, there are so many guides that explain you how to build these wells. If anyone have doubts, we can speak about it. But bear in mind that efficient ventilation connected with collection elements. Okay. Also, I let you hear a slide with a Canadian regulation that speaks about minimum flows and minimal pressure drops we need to take into account in order to project in function of the square meters we will have in our dwelling. So as we said, I will share with you the presentation so you can use this Canadian regulation in order to project your project. Okay. So let's talk about the third solution, that is the creation of an overpressure, the creation of a positive pressure. I think this is one of the most useful, most balanced between the price and the efficiency of all the solution we will present to you. Overpressure is normally used, for example, in the theaters, in the hospitals, in the places that the people are more vulnerable. So overpressure is a very, very good strategy to avoid all pollutants from outside enters inside our buildings. Okay, not only radon, but also particulate matter, organic volatile compounds, these kind of things. So normally we need to take into account the tightness or the leakage points in our building. For example, it's very common here in Spain to use this strategy for the parking offices we could have in the car parks, for example. So we need to take into account that we will use normally more flow than normally we will use for healthy reasons. We need to plan the ventilation system working with a constant pressure control, because we need to maintain an overpressure constantly inside the space. Okay, and how we can reach this is very easy. We need to supply more air than the air we are extracting, mechanically speaking. So this is an example that you can use like a guide. Okay, as you know, here in SODECA we are expert in pressurization of a staircase, for example. So using the regulation for a staircase, we can calculate the extra flow we will need to create this overpressure. So if any of you have doubt, I can share with you this regulation we use, for example, to do this example. So take into account the leakage points, use a constant pressure control, and also as you know, we are using more flow than normally in this kind of spaces. Is very, very recommendable to use a heat recovery system in order to recover part of the energy we are losing using this higher equipment, the higher flow. Okay. And the last one strategy is okay, mostly for exciting buildings. If we don't have the possibility of use any of these strategies, we could also ventilate more the habitable spaces. Okay, the mechanical ventilation of the dwellings, of the buildings, should be mandatory, but there is the possibility of increase this ventilation in order to dilute the radon. Okay, the radon is a gas that is not present in the outside air, in the atmosphere. So if we introduce enough fresh air and we extract enough dirty air, we will dilute the radon and we will solve also this problem. There are so many studies speaking about the diffusion of the radon. Here is an example that you can use to find your solution. But normally, again, implies use more air changers, more flow that normally in normal occasions. So again, we will have this key point with this recommendation that we need to test, we need to measure and target the problematic areas. Okay, it's not a question, it's not a matter of increase the ventilation in the whole building, because probably we will have some spaces that we will have the problem of the radon and other spaces that we don't have this problem. So the first point will be to test, to target the problem areas. Then we need to promote the diffusion and the renewal of air in each room. Okay, this implies, for example, to install the sleeves of supply and extract in opposite walls inside a room. For example, in this position the supply, in this position the extract sleeve, and make sure that we will have a very good diffusion, a very good renewal of the air in each room. Then again, we need to avoid the creation of the pressure inside the building. We need to avoid the negative pressure inside the building. It's so easy to create the pressure inside buildings because, for example, we have option for the dwelling ventilation that only implies the mechanical extraction. If we only have mechanical extraction, it's probable that we are creating a negative pressure inside a building. So again, it's very important to have both supply and extraction using mechanical ventilation. Okay, again, we need higher flows, we need higher equipment, so it's very important to use heat recovery units in order to recover as much energy as we can. Okay, and in the end, all the solutions we talk about it are better in common. Okay, so we need to bear in mind the combination with other solutions, with isolation solution in case it's possible, and other solution if related with ventilation. So it's very important to combine this solution in order to reach our objectives, our goals. Let's finish the presentation. Just I want to remind you that SODECA has expertise in every ventilation system you will have in your building. In fact, we have in the past year microlearning speaking about car park ventilation, pressurization of the staircases. These are very good examples of ventilation for safety. We also have another kind of ventilation system for improve the health, as we saw in this microlearning speaking about radon. So we have enough expertise for you to help with any project, any consult you will have in the future related with radon or related with any other ventilation solution you will project in your building. So this is a call to action. Please contact us if you have any doubts, any consult. I'm sure we can help you with your projects. So that's all. Thank you so much for your attention. This is the time for the questions. So if you have any question, please write the questions in the box. And meanwhile, I will share with you the presentation. Okay. Let me share the presentation with you. Okay. Okay, I'm giving you time to write your questions because I'm sure you will have. Okay. Okay, it's now uploading. So in a couple of minutes, I think you will have the presentation. Again, if someone have problem downloading the presentation, you can write me. You have my email here, and you can write me, ask for the presentation, okay? So I don't know if you have any questions. I'm sure it's because you are shy, because this was a very short presentation. Okay, I think you will find now the presentation in PDF, so you can download it. So I don't see any questions. Okay, yeah, we have questions. Okay, we have a question for our colleague Christy Lahoud. We said that the extraction from soil is an option. Can you please explain how it is done without blockage of the air pathway with soil? Yeah, very good question, Christy. Let me share with you again the presentation. And Christy, that's why we need to use these elements, extra element, the collection elements, okay? Normally, if we have radon problem, we will have a very porous soil. So naturally, the radon it's escaping, is releasing from the ground. So if we use this collection well, these perforated pipes or these wells, we will be sure that the airflow is not blocking. Again, probably we will have more pressure drop that if we plan an extraction from a normal space without the soil. But the key factor here is the use of these collection elements that will allow us to reach, that the radon reach these collection elements, and we don't have this blockage you are asking for. Okay. Okay, we have another question from our colleague Etelvina. In the strategy containment space, when can we propose to the client insufflation? Etelvina, I think we can propose it in every project. Okay, it's not you know, a strategy as studied at the other one. Okay, normally the studies we will have will speak about extraction, but in my opinion, if the isolation of the building is really good, makes sense to use the insufflation, because we will have the problem of help radon enters in the building. Okay, so if we have if it's an existing building, will be more difficult, but in a new buildings, if the isolation we plant in the building is so good that we can create the overpression without affect the enter of radon in the building, I think is a better strategy, the insufflation, okay, the creation of an overpression in this containment space. Okay, I hope this was clear. Okay, another difficult question, Etelvina. How can we calculate the airflow in this method, containment space? Okay, as I said, Etelvina, it's very difficult because there is no regulations. Okay, probably the best option for us. Okay, let's talk. We had in the past 20, 30 projects related with radon and with the containment space. In 90% of the cases, with 1 to 2 air changes using the space we will have in this air chamber is enough. But my recommendation will be, okay, let's plan 2 air changes, but let's use a speed control. Okay, why? Because if we have a speed control or we have 2 velocity motors, we can adjust the velocity, we can adjust the total flow, and we can save some energy. So it's impossible for us to ask clearly to this question, because there is no regulations that explain to us how to calculate this airflow. But as I said, in our know-how, 2 air changes is mostly enough to eliminate the radon in the containment space method. Okay. I don't know if we have more questions. Really good questions. Thank you so much for your time. If not, I hope you enjoyed this microlearning. This is the last microlearning of the year. We will come back again next year with more important or interesting training. So thank you so much for being here and see you soon, I hope. Bye-bye.